Okay guys, so I want to reiterate with you guys and talk to you about last week, if you can think back. We did our math interest survey, so it talked about if you liked math, it talked about if you think math is important, and if you think that math can really be used in the real world. Many of you said yes. Afterward, we took a short quiz based on adding and subtracting fractions. And one of the things that I noticed that we struggled a little bit with as a class was justifying our thinking. What does justifying really mean? What does it look like? Okay? And so what I wanted us to focus on today is our objective. I can solve multi-step word problems using visuals, but not just solving them. I want us to be able to comprehend what it means to justify my thinking. So, our driving question, what's going to push us today, is going to be when you show your work, can others understand how you got your answer? And what might that look like? So thumbs up if you guys have ever, in your time of learning, said, oh, I got the answer in my head. I don't have to do work on paper. I got the answer in my head. Quite a few of you, right? And sometimes that's easier to say because it's less work for us. When really, we don't want a paragraph of explaining what you did. We just want to see in your mind what you did to get your solution. Okay, that could be adding, that could be subtracting, that could be multiplying or dividing. So what I've got for you today, and everyone's got it on your desk, it says justifying your answers in math. Thank you, Martez.
I'm sorry. Oh, yeah, my goodness.
So here are some language stems that you can use when you're thinking about showing your work. Okay, and here it says, label all your work and make it clear. Show all of your work and use models and equations. Explain why you chose an operation. Explain how you know your answer is correct. Maybe do it a different way and try and figure it out.
What?
Okay? So, David, can I have you in your seat, please? Alex, can I also have you in your seat, please? Thank you.
Yes.
So, you guys are going to keep these in mind as we're going through today. Now, to start off, I want to model something for you. I'm going to show you guys a quick story problem. I want you guys to see it in 3 different ways, 3 different justifications. And when you look at those 3, in your mind, I want you to think, if I didn't know how to solve this, could I use the steps the student did to solve the problem? Okay, so that's what we're going to be focused on today. So right now, we're going to take a look at a quick story problem. Okay. Christian B, eyes on the board, please. Our story problem says, Christopher bought 92 Pokemon cards at the store. If he kept 4 for himself and split the rest among himself and 5 friends, how many cards would each student get? Taking a look at the number 1 over here. I did it in my head. 88 divided by 6. Pablo, please have a seat. 88 divided by 6 equals 14, and with the remainder of 4.
Yeah.
Thumbs up. Hold on. Thumbs up if you looked at that and that could help you solve a problem. Just by looking at, I did it in my head, 88 divided by 6, 14 remainder 4. Thumbs up if that could help you solve a problem.
Nope.
I got a few maybes. But what about this one? Okay, the student still got 14 remainder 4, but you see all this work. They might have done it the long way. I can tell here that there's 14, right? That's their groups of 14, and there are, okay? And then down here I can see the remainder of 4. But that seems like a lot of work, doesn't it? There's not really any labels. There's not really any other writing on there to tell me why they're subtracting, what they're subtracting, and what they're trying to get. And where did this 88 come from up here? There's no 88 in that word problem. Yes, Travion?
Are we talking about like reality?
Yes.
Oh, reality. Reality?
Yep, we're bringing it to the real world.
Okay. Reality. We're gonna have real because Mr. Kyle will take them all. Mr. Kyle will take them all, and you want to give them anything.
Okay. So let's take a look at number 3. This is student number 3. I want you to be thinking to yourself, Christian, could you use this information to help you solve the problem? I see 92 minus 4. Okay, so what is 92? What's 92 in our word problem? Number of his friends. How many friends does he have in our word problem? I'll take a quiet hand, Carla. 5. But it says himself and 5 friends, which is actually 6. So that's where the 88 divided by 6 comes into play. He had 88 cards left after he kept 4. Okay? And then he had to divide them.
I got it.
Thank you. So if I'm looking here, I can tell this number is all 88, and he divided them equally. Well, then he got down to 4. Why do you think he left 4 over here and didn't put them in the groups? Why did he leave 4 off to the side? Yes.
Because they wouldn't be even if Mr. Card put in any.
Perfect, it wouldn't be even. If I took this 4, I couldn't put it in there and make it even. Okay, so I'm going to have to set it aside. It's my remainder. So down here it says 14 cards per kid with 4 left over. Do you guys think now if you saw that justification that you could solve the word problem? Yeah, this one would probably be a lot more easier, wouldn't it? Excellent. So now that we've looked at what it looks like to justify, what do we see here that we don't see here or here? What are some things we see, Pablo? Hey, what are some things we see, guys? We see numbers in both. What else? What else do we see in both? Maya, you see subtraction in both, okay? What else do we see here that is not here or here? What really helped us in this problem solve it that way? What really helped us, Christian? Okay, do you guys also see this visual right here? These are visuals. Okay, it's actually showing you. Can I have you sit down, please? Have a seat.
I'm making him one.
So that's what it's going to look like when you're talking about your visuals, when you're justifying. Okay, this is much more explained than some of the other ones. All right, so we're going to go ahead and try this next one together. Okay?
Here, Luis.
Go ahead and quickly and quietly take out your math notebooks. Take out your math notebooks, please.
Be safe. Don't run in the class.
All right, here we go. All right, so here we can see. Oh, I'll wait. We are way too loud. Thank you. So we're going to actually work on this one together. Okay, it's our first one. So we're going to talk about Olivia and her quarters. That's the first one that we're going to work on together. Please open up your math notebook to your next clean page. Okay. So Olivia had 11 quarters. If she spent 4 of them buying a soda, how many coins did she have left? So let's go ahead and talk about what we notice here. What do we notice in our word problem? Zanaya, go ahead.
I have to.
Go ahead. Yes.
I noticed that Olivia had 11 quarters
She has 11 quarters, okay?
and that she spent 4 of them.
She spent 4, okay? So 4. And if she spent 4, would I be adding, subtracting, multiplying, or dividing? What operation would I be using?
Subtracting.
Oh, I'm looking for a quiet hand. Jonathan? Yes, I do. Okay, thank you. You're going home.
Lucky.
All right, so we're taking a look here. Brian, I asked you, we spent 4 quarters. Is it add, subtract, multiply, or divide? Subtract. Awesome. So you. So we know that we are subtracting.
Thomas Clemens.
Okay.
It's already time.
How might we use a visual to show this? How can we show this as a visual? How many quarters did she start off with? Zanaya?
11.
11 quarters. So let's go ahead and draw 11 quarters. So I went ahead and drew 11 quarters, and then we subtracted 4. So let's go ahead and cross off 4.
That's so easy. Wait, us?
So it says how many coins did she have left? So let's go ahead and count the number of coins she has left. Ready? Let's count together. 1, 2, 3, 4, 5, 6, 7. So she has 7 coins. So I'm going to go over here and make another label and say 7 coins left. What's another way that I could show this visual without drawing out the coins? Ashley.
11 minus 4.
Oh, okay. So you said I could do 11 minus 4, and what does that give me? 7.
5.
Okay, and what does the 7 represent, Ashley? What does the 7 represent?
The numbers of coins.
Okay, so we're going to put coins left. Awesome. And 4 is the number we subtracted. So coins subtracted. And then the 11 is what? What is our 11? Zanaya?
The 11 that we started off with.
Yes, the coins we started with. Nice job. So did you see? Am I writing a ton? Am I writing paragraphs?
Yeah, no.
No. I simply drew a picture. I labeled my picture so you guys know what I'm doing. I used some operations. Subtraction is my operation. Okay? So it's not just saying 7, right? It's not just saying we got the number 7. We went back to our page and we looked and we did 2 different ways to justify our answer. We found 2 different ways to do it. We used visuals and we talked about our labels. That's another thing. That's why we want to use justifying. Okay? All right, so now that we've done one together, I'm going to have you guys do one quietly on your own. And this is going to be our closure. Okay, so we're going to wrap up our lesson by seeing if you can do it on your own with a question that I give you. Okay, so remember, you can use this to go back and you want to really show how you can justify your answer. Okay, so I'm going to put it up here. You guys are going to quietly work on it on your own. Yeah, I'll make it a little bigger. Thank you for asking. I'll make it just a little bigger.
I thought you said that you were going to make it.
There we go. And I'm going to bring it down just a little bit.
Do we have to write the math question?
You do not have to write it out. No.
Jerry? Jerry. Hey, J.R. What's up, Leslie? My bad.
Jerry's freezer had 30 ice cubes in it. If he had to get 6 ice cubes, get ice for 6 cups, how many pieces should he put in each cup to make each cup have the same amount of ice? You're going to go ahead. You do not have to write it down, but I want to see you justify your answer. Look back on your paper. What are some ways you can justify? By labeling, by drawing visuals, by showing your answer in more than one way. So go ahead. Work this one out. I'll read it one more time. Jerry's freezer had 30 ice cubes in it. If he had to get ice for 6 cups, how many pieces of ice would he be able to put in each cup so that each cup had the same amount of ice? So go ahead. You're quietly working on this as your closure piece.